Hi, good afternoon, everyone. My name's Paul. I'll be presenting the webinar today. Just hoping you guys can hear me. Somebody can let me know in the chat window or by answering. Hi there, Pat. Thank you very much for letting me know. Hope you guys are doing right in this lockdown period. I don't know if you guys have opened up yet, but welcome to the webinar. We're going to give it a few more minutes until 2 o'clock, and we're going to start. Pat, I'm just checking if you guys can hear me. Okay, that's fantastic. Thank you very much. Yes, no, we will be recording the sessions and we'll be uploading them afterwards for anybody to watch afterwards as well. And it's actually really exciting. I'm enjoying tremendously the technology and learning how it works. What it is, BIM 360 is quite a wide-ranging platform, and I've been enjoying it tremendously. Hi, Rosanna. We've got Gerard and Rosanna. I know we've got a few others that are also interested and might join us a bit later. We are set to start at about 4 minutes from now. Just for the record, the guys that have joined already, if you have any questions or if you'd like to put some questions into the chat message during the presentation, I will be having a look out and seeing if any questions do crop up, and I will be I'll try and deal with them as they come out. So you can just type in there anytime. Great, loud and clear, epic stuff. We've been playing with a combination of InfraWorks, Plant 3D, Advanced Steel, and Revit. Wow, okay. Makes basic design work super simple. That's great news. Okay, thanks. Yeah, so that's very interesting. I know I've also used Civil 3D and InfraWorks. InfraWorks I use just to get the basic topography from the GIS data that it draws on, and then brought that into Civil 3D. And then I also shared the surfaces that I created in Civil 3D through into BIM 360 and used that within the Revit models that I've got. Plant 3D, I know that Quinn is working with that. So we've got somebody in the office as well that is busy with that. And which one is left? Advanced Steel. Yes, so Advanced Steel is still on my to-do list. But looking forward to that because I know that the South African library is out in 2020-21. And that's going to be really exciting that we can take our Revit models and take them through into Advanced Steel as well for the detailing. Of course, there's also Robot, which is the structural analysis program, which we draw on. So can't say I've got the complete suite around the building yet, but we're working towards that. Specifically now with COVID as well, we are looking at the BIM 360 platform to help people work from home as opposed to in the office. And I think a lot of talk has been around. I know I listen to a lot of podcasts from various different parts of the world And everywhere people are talking about, look, you know, people are probably going to be working a bit from home for the foreseeable future and probably getting into the office for a day or two in a week, going for meetings and maybe meeting some clients, but for the most people will be working from home. So this technology is really beautifully suited towards that. But that is amazing, Gert. If you don't mind me asking, Gert, how many guys do you have working on this project? See, Wayne has joined us as well. 4. Okay, that's great. That sounds about right. Yeah. Right. No, that's very exciting. And you guys are using BIM 360, I take it. Yeah. Ian Taylor is with us. Sure, we've got quite a crowd today. That's wonderful news. Excellent. Okay. Right, guys, it's 2 o'clock. I see we've got quite a crowd. Welcome. I'm going to start recording the session now. And it should be available for reference later when we upload it to share with everybody. So welcome everybody to this webinar, BIM 360 Coordinate. Coordinate, and this is about clash detection essentially, focusing specifically on Revit models, but also note that 3D DWG files as well as IFC files can also be accommodated within this workflow. And we're going to have a look at specifically the Revit workflow today, but remember that it's just as applicable to IFC and 3D DWG. And let's get going. So on the agenda today, we're going to have model aggregation, or how do we get a model to perform for us within BIM 360 to do some clash detection, and then to do the actual clash detection itself. And what you can see on the screen there is just a picture of Big Ben there in London. And just to get the idea across that these technologies and the protocols that govern this typically has been initiated and used by governments, like for instance the UK government, and all around the world people are now using this technology to save a lot of money. Typically clash detection on a construction project would save you about 1/5 of the cost, which is a lot of money if you then take that is applicable to a lot of buildings. So model aggregation, how it works in BIM 360 is once you've subscribed to the service, one would create coordination spaces. Currently, there's a maximum of 20 spaces, and we can now create them in the project files folder. So this came about, I would say, in the most recent version of Revit 2020 in the API, Revit 2021. And what it means is that one can no longer save a Revit cloud or design model into the plans folder in BIM 360. We'll see that in a moment. But you can now save it into the project files folder. So just note that change. And then what it contains is to create a container file, either a cloud model or a design model. In either case, when you save a Revit file as a cloud model up into BIM 360, that's not a workshed file, but the design file is a workshed file. So it's a similar situation as if we're working on a local area network with just a standalone file and then a central file. Then we can link models in from, I cannot see your screen. Could I be doing something wrong? Wayne, I'm not sure. Can everybody else see my screen? Yes, Gert. Yes, yes. Wayne, I'm not sure what might be happening on your side. I take it that you would have followed the link to the TeamViewer session. Rosanna, you're with us? Yes. Okay. Well, good good luck with that, Wayne. Just remember that we will be recording this, so I hope that you gain access to that through TeamViewer there on your side. No, it's a pity, but let's hope that you can get that right. Okay. And then we've got the shared folder. So if you don't know what that is yet, within BIM 360, that is where we share packages, and automatically those files will be put into the shared folder. I'll try and explain that in a moment. And then what we do is we use that container file to create some 3D views per discipline and then publish and extract the views for clash detection. So we've got some videos lined up that will explain this. But basically, where do we create these coordination spaces? So I'm going to start a little video and then we can have a look at that. This is where you can see the design collaboration space. This is where we can share packages. So that would be our central files. And we've got a whole workflow based around packages, which we can share. So within your own silo, you've got a BIM manager. Your BIM manager can share your package with another discipline or another silo, and they can then accept that file. So that's where the consumed part comes in. That is not a unilateral process. It takes at least 2 people to accept the workflow. There we can see that the coordination folder, we can now delete from the plans folder, and we can just work in the project files folder. So they've changed the API. So I prefer to work in the project files folder now. And then right at the bottom over there, we'll see that we've got that coordination folder that I'm showing you now is the one that I've created for the clash detection. And within that folder, I've created a design file, although it's not part of any team. All right. So it's a work shared folder. And then this is the shared folder. So when you create a package, Wayne, that's great. Welcome. So when we create a package, it's automatically unilaterally going to be placed into this folder. So it's not the bilateral or multilateral workflow. It's a singular, my files are ready for sharing, and there it is. So it's more a live process where the BIM managers are saying, look, we can share our files. So this is one of the more interesting workflows, and there you can see that the design collaboration, this is just to show you what that looks like. We're not going to deal with that during this session, but just to show you how they envisage, or how we envisage this technology to be used. Right, so there we've got our teams, and this is where we would share our packages from. And as soon as we share a package from here, then it's going to be placed within the shared folder. Right, so the shared folder is going to be the first place where my package is going to be available. It's essentially a published model. But each discipline's BIM manager, as soon as they share that package, is going to be available for me in that shared folder. Okay. So this is what the schematic looks like. On the right-hand side here, we can see our work shared file. So that would be the equivalent of the Revit design file. Remember, that is an invisible file, which then becomes visible in the teams when you publish that file. And then once it is shared, it puts into the shared environment, then we are linking that in to a larger file, and which is then going to create our clash detection for us. Right. So it's all based around that technology. So first we get working with Revit in the cloud, then we get work sharing in the cloud, and then what we do is we use those shared folders in that common data environment, and we put it into one file, and we're going to clash detect with that into the container. So you might see, yeah, I've changed, this is available on the internet, but they would say here plans folder. I would recommend you use project files folder now from Revit 2021. So this is, first of all, how to create work sets in 2-tier models. This is what I would recommend for you if you are using Revit. Right, so you can see there I've got my design collaboration folder where I can load some of my models, in this case architecture, and there I've got one of my 2nd-tier Revit architectural models. And the idea behind this is that we are going to use work sets to create elements in per level. So that's one way which you can approach this. You can approach it in various ways. There you can see all my work sets, and they are open. In the visibly graphic overrides, in the work sets themselves, you can see how per view you can hide them, and then you can show a specific floors work set. And the nice thing about this as well is you can very quickly check whether any of the elements that you've created in your model fall outside of the workset, or something's been included in the worksheet that shouldn't have been included when you switch on the section box. So that just creates a little box around all the elements that conforms to that worksheet. You can see that's nicely packaged. So there's nothing that's sitting outside of that scope. So I'm quite happy with that. Here we've got a little bit more of the file. I'm just going to switch off the curtain walls. Then I can show you how that would look for the different work sets. If we view this per, there's all the work sets. Bottom over there, there's the linked files. We can switch those off. So you can see there's very little content yet within the architectural file. Most of it is in the structural file. But if I view that per work set and I view it from the side, then we can see how they conform to a specific levels work set. So like most things within BIM protocols, it takes a bit of setting up to start with. We'll just quickly have a look at the structural model as well. And it pays to do the work up front. So what I always say to guys is preparation is 90% of the battle won. So if you can prepare properly for how the project is, and if you're very diligent and almost obsessive compulsive about this to start with, then we can set these models up for success later on so that we can clash detect like this. And you'll see how this comes together once we go into the container file. There we go. You can see how each level is on its own work set. Again, it just helps me to create the 3D files. Those of you that know Revit will see that when I have it over there, it actually shows a group, so it's also relatively easy to save that upwards. Again, it's the same process as what we showed during the architectural model, and it's just very simply to show you the ground floor. In this case, the ground floor is switched on within this view, and when we switch on the section box, then we can see all the elements are contained within that one area of the drawing. So we're confident that we don't have elements outside of this level that are going to clash detect with other elements. So we stand a good chance on that level, at least, that the elements are going to be great. All right. So this model is using the CM, the coordination model, within the name. And this is now what it looks like. So within this file, we've linked in both the architectural and the structural file. And now we're busy setting up views that are specific to architecture and specific to structural. Right. So if we look at the view template there for the architectural view, we're applying an architectural view template for the architectural view. And then note also with the Revit links that we do not include that in the view template. The reason why we don't include the links is because we want to manipulate them afterwards within visibility graphics overrides. So because visibility graphics overrides is not included within the view template, we can now go and have a look. Clearly, our model categories are locked down, our work sets are locked down, showing there the architectural model A1, that is the level range A1, and there's the actual links that we can control. Right, so because the Revit links were not included within the view template, we can now override the work sets within that architectural model that we'd like to see for this view. and that would be the ground floor. So we're creating a 3D view showing us only the architectural work set relevant to that floor. And those are then the elements within that architectural file for this level. You can also use section boxes to achieve this. I've just found it easier to do so through work sets. Now there's an example of how a bit of extra work at the beginning makes my life easier later on in the project. Similarly, for the structural 3D view, we are switching on the workset for the structural model. And we do that for every level. We do this properly, and then we go to the publish setting. So when we do publish of Revit files, then what we are saying is when we load this into the published area of plans or into a coordination space, then all the published views that we have there will be extracted. If it's a 3D view, it will be extracted as a model or a model element within the coordination space, which means we can clash detect using that. And you'll see that shortly. And there we go. I'm synchronizing, I'm saving to the cloud, and then I'm managing the cloud model, and I'm publishing this cloud model so that those views can become visible. So you might remember that my coordination file, this file, the container file that I've created was a workshed file. So I have to publish the latest version for that to become visible on the BIM 360 platform. Also, just looking at where the links originate, you'll see that they come from the shared folder. So I'm not changing the link path. I just want to show you where the link path comes from. That comes from within my project files folder, in the shared folder, in the architectural folder. That is where we are linking from. So we're not linking from the consumed folder, we're linking from the shared folder. So it makes it all live unilateral decisions by the BIM managers to share. And then as soon as we've shared, then our new elements will be available for the other guys that are involved in the clash detection to get a heads up and to see where elements are going to clash. And then we're going to look at the actual clashes, how we can set that up. So after we've published that file, automatically these views, where are we? There we go. Automatically these views are now extracted. You can see AX040GF ground floor. That is one of the 3D views that we've published to the cloud. In the project admin, we can see that we've got the model coordination spaces, which we can create or deactivate if we want. And we've got that one at the bottom over there is the one that we're going to use. And there's the model coordination module that we've got access to. So there we can see all the views. If we select search for models, if we use ground floor as a search criteria, there we can see all the views that are going to conform. So we've got our architectural and our structural ground floor levels. And you can filter them according to your naming standard, whichever protocol you're working with. And on the right, you can see immediately that there are some clashes. So if we select those views, we can select one of them and actually have a look at it. So it's got a bit of a viewer built in. And that should look familiar now. We've seen that also within the architectural Revit file. That's what it looks like. It's very easy to navigate these views. If we switch on the second model and view that, And you'll see the difference as the structural model is now also included. And so you can load in all the different disciplines if you're all using the same naming nomenclature. That's then relatively easy. What's nice about doing this in a container file is that one can have somebody that's responsible for setting up the naming convention for creating the views, and they can control the visibility of the models throughout 3D views, so that will make it consistent. So it's easier to manage if you have somebody that's expert at clash detection. That would be the equivalent of somebody that can use Navisworks or Glue in the older workflows or in the alternative workflows. I'm convinced Navisworks still has a great role to play within the construction sector, but of course this technology over here, to my mind, is even easier and to some extent faster because there's no real work to be done as such. It's linking in the models, and then immediately it's doing the clash detection, and it's available for anybody to see. In addition to that, when we create these clashes, we can then also assign them to people, or assign them to companies, or assign them to roles, which means that they would be able to work with the clashes immediately. Now there we can see the views that we have created. And because we've saved a view, it's now very easy to browse to that view to see what's going on. So in this case, we named it in the architectural fashion. We would probably also want one for the structural discipline, similarly for mechanical and electrical, maybe ICT. And the reason we want to do that is we need to understand from a discipline specific what we are doing. So in this case, it would make sense also because we are clashing with the structural with the architectural. We are switching on that floor with the floor above and below as well, just to see maybe there are elements that are extruding beyond the architectural elements for this floor and into the next floor. In this case, there isn't too much visible on the next floor. In fact, there's nothing visible on the next floor, but we'll see the same situation in the structural sense next. There we can see that we can choose which model elements we want to report the clashes from. Okay. But we are going to create yet another view for structural to go and view exactly the same one. And you can see it's got this wonderful sort of color-based and automatically invisible. If you click on each one of the clashes there, you can see them. All right. So what's nice about this, you can drill down into individual object classes, or you can even go into a type clash. So there it's looking at the type name of the elements, and then it will look for all the clashes with that type of element. So there we can see, for instance, all the beams that are clashing with the walls, all the structural beams that are clashing with the walls. So in a case like that, we can just say, all right, the guys that are modeling the walls, please go and cut out all the beams from your walls. So instead of creating a clash for each and every wall, we can just say, look, the beams are clashing with the walls, go fix it. And then the next time that we upload the latest published model, of course, we can see that we'll see that there are less clashes to report on. So that's one way in which you can speed up the process of quickly resolving clashes, quickly assigning them and resolving it, as opposed to just saying, all right, each clash on its own. We're just going to do the same thing in reverse for structural. Now there we've got the structural levels above, below, and coincident. There we go. There's actually some elements there. You can see the structural model is more developed than the architectural model. And now we can also just give that a description. So in this sense, we're going to have a look at the architectural elements and how they interface with the structural model. So once these views are set up for the project, then from then onwards, each time that a package is shared, the clash detection will update automatically. So as usual, it's the setup that takes a long time. It's the structure or the underlying structure of the models that are important. These things have to be discussed between the different stakeholders, companies, before the time. So we're seeing this from the perspective of, here we go, that makes it easy. And so we can see. So over here, we've got the curtain wall, and we've got some of those beams that are hitting the curtain walls, and there's some other clash detection. So we're going to have a look at the curtain walls. And there are glazed elements and there are mullions. And that is what we're going to look at next. All right, so we found some clashes, discipline specific. We're looking at this from the perspective of an architect. And we are now going to find out what we must do to fix this clash. So the first step first is we need to sorry, this is strange. For some other reason, this isn't. I hope you guys can see what's going on here. It's not enlarging. There we can see that we are looking at the clash. In this case, there are mullions that are clashing with a beam. And I'm going to indicate that it is an issue. There it lists some information for me, including the date by when I want to have it fixed and who I want to assign it to. In this case, myself, but it could be somebody else, right? And then maybe also description of what I should do. I can either delete what's there, but I think it should be pretty self-evident. If somebody could see this, they would immediately catch on, look, there's a clash there, fix it. You know, they should know how. So usually it won't take too much describing, and we'll see how that is fixed in a moment. So the mullions and the panel, of course, is going to be the same thing. So if we change the panel, the way that the curtain wall is constructed, then both of those will be fixed. So in this case, we're just going to say, you know what, that's not an issue, because we're going to fix the clash with the mullions, so the panel's automatically going to be fixed. So I'm just saying there, it's other, and automatically, if I fix the curtain wall, then that's not going to be an issue for me. Okay. They're just saying it's not going to be an issue. We can have a good look around the model, navigate it to see what is going on and where we've got clashes. Okay, so you can see it either by type or by instance. So somebody who knows what's going on then must go and say, all right, this is a clash, that is a clash, that is a clash, fix it like this, fix it like that. Or just go and fix everything that is conforming on that type to that kind of clash. But you can easily navigate through each one of those elements and visually see it on the right. It's very nifty. There we've got the type name. There we can, again, just put a dot somewhere. If it's an individual clash or type, it doesn't really matter. It's going to indicate all of them. Again, we put a date, a description, and there we go. So obviously the next part of this is we're going to have to fix the model. Once we fix the model, we're going to publish it again. And once it's been published, we also need to publish the container model. And then once the container model is published, then we can see the updated clash. And that's what we're going to have a look at next. But for now, we can have a look at the issues there. You can filter and sort issues as well. Or you can go and have a look at a specific issue and add information to it. You can put attachments on there, pictures, drawings, information. You can also view an activity log of what's been happening on that issue in time. So if you want to follow up as a manager, you can have a look at what the guys are doing and what information they are giving to you. You'll see that within this interface, at least, the clash that was indicated was not an issue is not available to you. That's not to worry. You can always change that, but we have to go to a different place for that. So while we can filter clashes over here per type, we can't see the ones that were indicated as not an issue. Even if you switch all of them on, you're not going to see them. Okay. So while you can filter by all the other information, who it's been assigned to, etc. So this is where we close it, and now we can see all the different models and the clashes between the models. If we open up those models, then we can quickly see where there are some clashes. So that sort of grid view, in my instance, I don't find it all that useful, but it's nice to have a quick overview. It's like, okay, you can see very quickly, color-coded, where's there a lot of trouble. Then you can pick out those models and say, right, I need to have a look at those models to go and see where the clashes are. There's all the closed clashes. That's the one you can see that we said it's not an issue. And you can also reactivate that and have a look at that. Right, so even though we did have a clash which we said wasn't an issue, we can still go and change that afterwards. You must just know where. And then we've got our views again, which we can very quickly navigate to. So the user interface really is quite easy. The only, I would say the only thing that wasn't intuitive initially was to see how one can change not an issue clash to something else that it's required to be. So if you compare this to Navisworks, where we have to create selection sets or search sets, then selection sets, then create clash detections from them, that's less work, I would say, than what Navisworks is, but it's still a very quick feedback on where there are clashes within the models and what we can do to resolve them. It's automatically in one source of truth, one source of information, and available to anybody that's got permission to view them. I think the one element which is not as strong as what Navisworks would be is being able to switch back into Revit. For those of you that's familiar with that, is where we can navigate into the Revit model where there's a clash. So one would just have to find those elements. But the other nice thing about clash detection within BIM 360 is it gives you the element IDs of those elements, right? So you would be able to cut and paste and select elements by ID within your Revit model, maybe type BX within a 3D view to isolate that element. So there are ways and means that we can work around the switchback issue. Okay, so in that case, I just showed you quickly that we fixed the curtain wall, and then after we've done the architectural publishing, then we would just have to publish our coordination model again. And this is what this is about. We are publishing that coordination model so that those views are now updated in the coordination space. And then remember that the clash detection will then automatically be updated. So it becomes a bit like a conveyor belt. Every time that we share a package, then we're going to publish the coordination model, and we can see the updates to the clash detection. Maybe just make a few notes to say we fixed something, close the issue so it's not an issue anymore. There we've got the wrong project open. That's 20. I'm going to open the right model on the correct shared area. It's updating the clash detection there. You go to the issues, click on those issues to highlight them. And there we can see it's not picking up a clash detection anymore. So we can close this. So that's done. No clashes there. So everything that's been assigned to an issue, it's either been assigned to an issue, indicated as not an issue, or it's been fixed. And there's the tracking of that issue. It's closed. I think lastly, also see on the home page, it's quite nice the fact that you can open your home page in the morning and have a look at what's happening within BIM 360. And there you can see the project issues that's been there. Are type of coordination. So immediately, if I've assigned something to somebody else, when they come into work in the morning and they open their home page, they can see that they've got some clashes that they must go and fix. They've got some issues that's been assigned to them, and they need to go and fix their models. Gives them some information, tells them what to do. And they can update that issue with images or whatever is required. And if they have a look at the linked document, it's automatically linked to a document. And there they can see where the issue is. Okay, so if an issue has been assigned to someone, it should be a relatively simple simple process just to go and fix that. Okay, so from the BIM managers through to the production side, that is the workflow that we follow. And we've been through that part of the process where we fix that and manage that. That's great. All right, then for those of you that don't know, there are some BIM 360 trials. For BIM 360 Coordinate, there is no trial yet, at least not what I can find. I've posted onto the forums to find out whether they're available. It seems not. So you can, however, also ask and request a demo. I would recommend that you chat to us as well. Maybe set up a meeting with us so we can see whether that's going to work for you. But then if you are not using BIM 360 Design and BIM 360 Docs yet, got until the 30th of this month to, of course, have a free trial during the extended lockdown. And then after that, if you haven't tried it yet, you've got a 30-day session. What's nice about these servers is you can at any time, you can go and see whether the service is up and running. Typically they are. But there's, you know, with the C cables breaking, you might want to know whether it's the Amazon server or whether it's South Africa with its cables. There's another web link over here for some frequently asked questions. And again, if you'd like to have some more information on this, please contact us here at Micrographics so we can assist you in using this technology. Like I said, I find this technology fantastic. It's great and it's quick. So I don't know if we've got any questions from the audience or the attendees at the moment that we can deal with. Now, if anybody's ever worked with BIM 360 Coordinate or tried it, I think a lot of people that are present or that are attending might have tried the working with Navisworks and Glue possibly. This is the newer technology that Autodesk is working towards. You're welcome to type your questions in the chat window or otherwise switch on your microphone if you'd like and just ask a question. If anybody does have a question. All right, so I don't see anything coming through. I hope that you've seen something that might have piqued your interest, and like I said, it's nice and quick, and it's automatic once you set it up. So I hope that you get the opportunity also to experience this within a professional workflow. All right. Well, with that, I'll thank each and every one of you for attending. It's been a pleasure to be able to present to you, and we're going to close. Thank you, Wayne. All right. If there's anybody else with questions, we can deal with that now. Otherwise, we'll conclude the session. Have a great day further, and good luck in the time ahead. How does Civil 3D fit? Civil 3D fits in. Thank you for that question. Civil 3D, and yes, this recording will be available later, Martin. Thank you. Civil 3D fits in that 3D DWGs can also be clash detected. So if you have a 3D DWG, you can upload that into the folder. It will recognize that as a model. And because it recognizes it as a model, you can be able to clash detect. So where I focused on Revit, you would be, instead of having a Revit model with 3D views, you can just upload your DWG file as is. and it will then go and clash detect. I think that is actually a very interesting question, Martin. Sorry, JJ. I just see the name here as admin 2016-JJ, but do you have a session for civil integration? Jacques from Le Cause. Okay, Jacques. Just typing down your name here, Jacques from. Jacques, it's definitely something that we can look into for civil integration. I specifically think that you're thinking about civil 3D. The other thing that might be interesting as well, I know somebody, they mentioned advanced steel. That's also an AutoCAD vertical, and it would be interesting to see whether those AutoCAD verticals also behave in the same way. So we can definitely test those for you and let you know on that. I don't have an example of that at this moment in time, but perhaps we can have a look at you specifically with that in mind. Okay, how does this differ from SharePoint or OneDrive, and how can it be integrated? So in short, none of this technology is available within SharePoint or OneDrive. The technology that you've seen now is only available on BIM 360. There are some other platforms that can leverage IFC files. This platform also can manage IFC files, but that's usually your BIM platform. So SharePoint, it's more Microsoft, and OneDrive as well, it's more Microsoft solution, and that's not going to give you the analysis of the CAD entities within them. The other thing that is great about BIM 360 as opposed to SharePoint and even OneDrive and so on is when you work with worksheet files, Revit files specifically, then there are technology built into BIM 360 that allows the data to be secure. We found even with VPN solutions that it's not that great. Okay. But yeah, please, great feedback. Please contact me to discuss integration in our business, Jacques. That would be a pleasure to do that. Very interested in Civil 3D and also how the CAD can help with that. We'll definitely be in contact. Thank you very much. Right, unless there's any other questions. Again, thank you very much. It's been great to be presenting to you. I hope you guys have a great day further and good luck with the business as we carry on forward. Thank you. Dankie Eneke, goed gaan.